Yeah, so I will start from here again. Yeah, some of you saw maybe some of you saw the like last day performance about two kids. And the system is about this, and the system is also about like making AR performance and also for the AR performance. So it is like supports the creativity for the musician. So they can manipulate the sound with gestures like really. And everything started with this ARCube, which is the first prototype. So as you can see in the picture, it is transparent cube in augmented reality. So it is developed with Unity and also Meta SDK, and it has four sound sources, which means like four objects inside, so the performers can manipulate it in real time. And it is also color coded, so it has like the red, green, and blue and yellow, which is really easy to see. So, so it has these four objects, and also the cube means the space. So the performers can use this space for also for the spatialization. And it also have the visual components like wayfinding, and navigation. So it has some indicators to help to find the good location during the performance. And also from there, so this is like my master's project outline. So I did a like usability experiment. So it's about like as you said, research about this AR interface. So from there, it can be developed to as a like the creative tool for the performers. So like we designed especially the AR performance two cubes to really deeper dive into the like creativity part. And also like I just finished the compatibility experiment for this AR interface to see the like possibility to share with also the other instruments and also the other performers. So and this performance system is like especially in the second part for the creativity. And yeah, this was the like the back story. And this is a bit of a background. So there was a computer music performance system developed in 90s. It is called like CMPS. And it was really interesting for me because it shows really good components for the like computer like performance system. So it described about the human performer and about like performance gestures. And it also describes the like it can be sent from the input devices and it like processed with the computer system. And it also shows the like connection between the IO devices and also it shows the recording. So it really shows the like the really important components like for the like performance system. And then from there, the question was, so the technology is emerging and now we have this like new really the really interesting new AR technologies and VR technologies, and in a broad term, like we can call it XR. So how we can use this like performance system in AR, and also like can it be used for the multi-user situation, or can it be like implement well during the musical performance? So that was the questions. And then this is our system. So this is AR performance system, which is describes like multi performers with hand gestures, and the performers manipulate the AR interface and its objects inside, and that location data sent to OSC. And SuperCollider process the audio and also doing the ambisonics encoding. And we use the external ambisonics decoding tool, and it connects to the like loudspeaker setup. And it also handles the instrument's live sound, and that is the one that will be processed like in SuperCollider. So the like location data and the sound processing part is like kind of mapped. So that is the like whole overview of our system. And in details, this is the air interface. So we can use grab gesture or pinch gesture to manipulate the like cubes or the objects. And now it is like have 6 degrees of freedom. So that means like we can send X, Y, Z, the Cartesian data and like along with the orientation data. So each air interface sends 4 by 9 parameters. So 4 objects and each 9 parameters. So like it handles total like 36 parameters for each device. So after we send the data via OSC, it has like 3 different sets based on the data information. So basically AED, X, Y, Z, or PRY, they're like all different sets and it writes to the buses. So we're using control buses, and so we can really handle the data individually and map the like audio processing part in real time. And yeah, this is, and before we actually processing the audio, there is a pre-processing step. So there is a sense for pre-processing sound that doing the like gain control and like low and high pass filtering, and also like auto gain and EQ adjustments. So it can really help to balance the sounds during the performance. And this is the components for making this like musical performance more immersive. So it is about spatial audio control, and it really helps like effective spatialization. So what it does is like so after the objects and the AED data, which means like spherical data, it's like splits the AED values into 4. So like 90 degrees intervals. So it becomes like this kind of shape. So 1, 2, 3, 4. So it is also like distributed sound with the objects. And this is about sound design part. So each object also can be designed with really desired sound with SynthStep. So it is really a useful tool for the performer because like they can just write a SynthStep and then they can use it for their performance. And it will control the data to use it with the locations. So, and for the 2 cubes, we use like for the red, there is a pitch and spectral spatial diffusion effects. And for the green object, feedback and delay is the main. And for the blue objects, we use bit crush and freeze effects. And for the yellow objects, it was like grain length and density. Yeah, that was us for sound effects for 4 different like virtual objects within ARCube. And there is a spatial rendering part. So like we mentioned before, there was a like spatial splitter, helps like immersive experiment. And also there is a like ambisonics encoding part inside of the SuperCollider. So this time we use like HOA class, like higher order ambisonics class, like in SuperCollider, and it really worked well. And then it is like now we are using like Windows like computer for the setup, like especially for the last concert. And it is like connected with Jack to configure the networks. And then there is an ambisonics decoding part, which is the part that we use external plugin. So we use the IEM ambisonics decoder for the decoding part. Yeah, and this is the example about how really can performer use this cube and how it really like shows like when we really use the cube during the performance. So based on the like location, these effects can be distributed. So the location data can change the parameters of each effects. And also, it was really interesting that to see how it is really working well during the real time. So even though like it is just mapped with parameters like based on the gestures and also the like the speed of the gestures, it can also generate the new audio effects during the performance. So that is really depends on the input characteristics and also like how the performer used this cube. So that was really a pretty interesting part. Yeah, then we will have a like live demo with this Windows computer.
Good. Working?
Yeah, share that.
Yeah. Just in case I need to say something or we need to reflect the. This is not going to be an audio demo. We'll just show how we. No, just need.
Yeah.
Yeah. Oh. Where's the shop? There it is. Okay, so yeah, we decided to do this streaming because it's so awkward to see people manipulate stuff that's not there. So that's an important. You see it, right? It doesn't. It's super bad. Should be larger, but still. Okay, so and what we're doing, like it's a. I hope this is worth setting up this whole computer here because it's a fairly simple. So here's the all of our like it's all jack based. Yeah, I don't know who works Linux here. Okay, so
Right, very good. Hi, how are you guys? My name is Juwon Park, and I will be doing a presentation about performing and sharing laptop ensemble repertoire. Actually, emphasizing much more on the sharing part. I think there is some needs to talk about this because well, a lot of laptop ensemble, electronic music ensemble performances. It's hard to do a repeat performance, but I think repeat performance or the additional performance gives chance for audience to find the work's value more. So basically, more you present, right? You just get more chance for good for feedback or a for the audience to actually think about the music and then maybe find some values or things to more learn. So I'm gonna give you some what I learned from writing and then presenting electronic music ensemble pieces, and maybe some guidelines on how to make your pieces or present your pieces so that you get more performance opportunity, right? So I think it is important for the creators to plan from the beginning to plan about repeat performances when you are writing a piece, meaning that these bullet points needs to be perhaps in the back of your head while you're writing. Well, while I'm writing, at least, I'm thinking about lowering the technical barrier and the cost, and then my piece needs to work without the performers actually contacting me to how to run it. And also, I'm gonna also talk about what it means by does not depend on the performance specific skills. So I think it's easier to talk about this when I show you a piece. So you can just click on the link on the website that you can get from the QR, but there is a link to a piece called a Singaporean Crosswalk. There are a bunch of videos you can see, and then it looks something like this. People, performers basically start the SuperCollider patch and they walk around. Then what they do is they see the instructions on their screen, and then they move and make sound according to the instructions on the screen, and then it can be performed by from 4 to as many performers you want to. And it has been performed quite a bit. So, oh, all right, you don't need to hear the clap. And it's basically when you want to perform this, you download the SuperCollider patch, and then the performers do not need to know anything about the SuperCollider because they only go through these 3 to 4 steps. All they have to do is they download the SuperCollider, they download the patch, and then evaluate file, and then it should be done. And then when they see my cue, and then it just starts. Okay. So as you can see, starting the piece itself is very straightforward. You just look at the instructions, and then you learn maybe like 1 or 2 things to run the SuperCollider patch, and then performers can get into the rehearsal right away. So in order to do so, right, I try to minimize using extension or extra installation of the apps, and then I want to make sure that when I design a patch, it is running in as few steps as possible. And also, for the case of the Singaporean crosswalk, only thing you need is a laptop. So I usually do not ask performers to purchase a new gear or try to investigate on other things other than the computer that runs SuperCollider. So that is kind of I mean it's when I'm writing a piece, I need to think about this while writing the piece. I have to make some choices over what gear needs to be used, and then how much of the SuperCollider knowledge the performers have. And usually answers for me for those questions is like a minimum SuperCollider knowledge, and then no cost if possible. Okay, so the result is I would say performers are not afraid of at least trying Singaporean crosswalk on their own. I hope the instruction is clear enough so that they don't have to contact me, a creator, to basically ask, hey, how do I do this? And that's what the score is for, right? When we are actually wanted to perform a non-electronic music, you get the score, and then you don't have to contact the composer to ask, hey, how do I play this, right? So I just want to show you the result of this kind of approach to the electronic music ensemble pieces. This is a record of me just keeping the who performed my piece in the past 10 years, and I just list a bunch of the ensembles that performed my ensemble pieces here. And then for my record, I just highlighted the events that I had to direct or interact with the performers to make the piece realizable. So all the unhighlighted cells that you see are the performances that has been done, rehearsed, and then presented without me basically telling the technical, me becoming like technical assistance or the someone that they have to contact me to just basically solve SuperCollider patch problem and those things. So I think having that kind of approach on like easy setup, and then the lowering technical barrier, again, I said, it gives more chance for the audience and the performers to evaluate a musical piece. And I think that we just assume that we don't, we cannot assume that in the electronic pieces, while we can do that when we are doing an acoustic piece. Because of that, I think, again, these things need to be thought through throughout the composition of electronic ensemble pieces, especially using programs like SuperCollider, in which we cannot assume that everybody knows how to use it. Something that you may have noticed also is that I'm not depending on the specific skills that maybe a performers have. It is kind of my artistic choice to not to depend on the improvisational skills of the performers, in a way that I am actually not writing a piece for like a super virtuoso of electronic music. It's just a choice for me. So that's what I mean by does not depend on the performance specific skills. Anybody who wants to try my piece, I think I want to make sure that they could do it within 1 or 2 rehearsals, or use my score or the performance instructions to learn about the piece, perhaps practice it, and then present it again without me intervening. So that kind of example on like communicating through notation, I could show that to you on the piece that I wrote for the game controllers, PS quartets. And then they are basically looking at the scores that looks like this. And if you are a gamer, this should not be a a surprise, right? There's a directional pad. PlayStation players, you know exactly what this means. So I try to use some notations that is familiar to the performers, regardless of their musical background, when I am writing instructions for the electronic music ensemble pieces. So you have perhaps someone playing like this. And they're all looking at the scores, and then they just connect the game controller wirelessly. Right? And then they will play according to the score, and then according to my movements as a conductor, in my hand movements as a conductor. Like this. So there's some improvisation elements in here. I'm, for example, improvising my hand movements, but it does not really depend on the performance skill, except perhaps their ability to read the PlayStation command control. Right, so what they are seeing is, again, this kind of score, and then there is I'm not gonna play it, but also there is a score follow version of how the sound is related to the what you're hearing is related to what you're seeing in the performance view here. Good. All right. Only thing that I have to do regularly is constant updates. Make sure that when the PlayStation 5 controller comes out, I want to make I just have to update the patch so that it works with the current controller. So some of the updates are needed for repeat performances, but the audiences and the performers should not be aware of these updates that I make. Okay, very good. So the benefits of doing this, I think, again, I hope that I was trying to convince you that the additional performance gives the composers a piece, my piece, basically more opportunity to be evaluated, to find something that could be useful for the performers and the audience. But also, this gives me a chance to refine my pieces. When you present your piece multiple times, it is inevitable that you find some flaws, something to update, something to upgrade. So repeat performance as a creator is very beneficial because I get a chance to test basically and then refine my piece. Okay, but also I think it's a good career move as a composer and educator. I think repeat performances is beneficial to the people who basically to my bosses to promote me, but who's also responsible for my promotion. But also, you get into the opportunity to participate or teach in the festivals. That just give you a link to the one festival and one concert series that I think I was able to get the gig because of the way that my patches are designed. So Nif North at the University of Tennessee played PlayStation PS Quartet number 2, but again, all these performances were done without me actually basically directing the piece how to do it. So it was all performed and then presented without my intervention. But also after this piece, I was invited as one of the guest artists a year after. And then the Cusp, this is a festival in Cleveland. And then I was able to not only do a presentation of my pieces, but because the piece, my patches were easy to run, I was able to do a 2-hour workshop before the concert with the Cleveland electronic musicians that I never met. We practiced and rehearsed a few electronic music ensemble pieces that use SuperCollider, and then we presented. So I was able to actually do this kind of a workshop plus concert of electronic music ensemble pieces, and then this was on my behalf a good proof that okay, my piece works with the many types of audiences that I do not know, many types of the performances that I do not know, and then I could play a concert using these principles. Okay, I think my time is up for talk. So if you have any questions, let me know, and I'll be happy to answer.
Also, Juman is the Peabody Laptop Ensemble guest artist this semester. We're doing a portrait concert of his work in like 2 weeks or something like that, which is good to mention. Questions for Juman? Juman, can you hear me?
You may have to, Ted maybe have to repeat the question, so I'm hearing you kind of, yeah.
How can I go up there? I'm just going to turn up the volume on that mic, but I'll repeat it if needed.
Okay, my question is, Juan, I remember what you said about you want to design your work to avoid virtuosity. You have everything very accessible. You don't have to buy any expensive equipment, and you certainly don't need to go into any sort of specific skill set. But is that something that you ever would try to pursue? Maybe do you think there's is there any potential for the development of a kind of virtuoso electronic performance practice? Do you think that's something that you want to be part of?
Did I understand the question that is there any my approach where I want to use the virtuosity of the performer? Is that the question?
Yes.
Yeah. I just presented some of the pieces that's written for the electronic music ensemble, in which I do not know the level of the ensemble performers. But my solo pieces, a lot of solo pieces that's written for the electric musician and electric musician or the performer and the SuperCollider, they are the virtuosity or the skills on their instrument is very, very beneficial. A lot of my solo pieces that I do, I think, I try to show my, virtuoso side of the electronic music performance, but also pieces written for a specific instrument, especially when it's written for a specific performer or performers. I assume I would love to show their years and decades of skills. I say about this less virtuosity for the ensemble only because I just do not know who's gonna be who wants to play these pieces with like 10, 20 people in the group. So I want to make sure that it's not, for example, like someone's like super good at like no input mixing, or someone knows I don't want to assume that they actually know like how to edit and modify my SuperCollider code to perform the piece. So I think that when I say about the virtuoso or the performance specific skills, I'm also meaning about I also mean about that they know SuperCollider very well, or like that. But I mean, there are a bunch of pieces that I think SuperCollider and the virtuosity of a performer meets, and then it can kind of yield an interesting result. And then for my practice, those kind of pieces, I write it for either myself or the specific performer, usually performer who does acoustic instruments or solo performance. I hope that answers your question. Yeah.
Thank you.
All right.
Other questions?
Hello. Hi. This is Bruno. I'm the director of the Santa Clara Laptop Orchestra. And I just want to say thank you first. I came across your Repertoire piece many years ago. And we have used that SuperCollider code for like many wonderful performances with my students. We have adapted it, make new versions of it. So thank you for that. It's been a lot of fun.
Oh, thank you.
Yeah, thank you. And we have evolved to actually arrive at some of the same principles you have been describing, which are really interesting to hear you describing. But I also get a lot of students that, I never know where they're coming from, and I have to kind of tailor the class, Ensemble sort of adapts to many different levels. Some of them are music makers and have lots of experience, and others have zero. So I'm looking forward for some of your other pieces you mentioned there. But my question was, how do you, when you're creating a piece like this with the idea of having like a high degree of accessibility, I wonder if you want to share a little more about how you also try to maybe embed some depth in terms of possibilities. Like if you have more experienced players, how can you challenge them to go a little further? Or the beginners, how do you make the piece a little challenging for them as well? What's the space you're trying to navigate and try to account for all of that? And basically have the performance also have fun in their own way, right? So I'd love to hear your thoughts on that.
Excellent. So if how do we actually add how should I actually add the depth if performers wants to actually get better at it and then get good at it? So I say the lower barrier in terms of the performance specific skills. It's basically what I mean was they can start the piece without actually thinking too much about their previous experience or the their SuperCollider chops. But for example, but they can get better at the things when they practice more. It's like games, right? I want to actually show you PlayStation Quartet piece again. I mean, it's a game controller. People who plays this piece usually are into games, and then it's like stage one. I mean, great. I know the controls now. Let me beat the first boss. That's great. I like to have fun. Then stage 2 and 3 gets a little bit more difficult with the bosses. So I think my piece, when I'm writing when I'm designing a patch, I want to make sure that it's easy to get in, but also there is something that you can do if you play around with this patch for like 3 hours rather than 10 minutes. So hopefully the pieces that I write that is easy to get in, but also there is some interesting points for the performers to explore. Let me actually give you some examples. So you just saw a little bit about the, I need to share the screen, sorry. Share the screen. So this is a kind of a studio recording of a piece, PlayStation PS Quartet number 2. This is like a, before the concert, actually right after the concert. And then they play the piece like this, right? So so maybe one or two rehearsals. I don't know exactly what's good, what's bad. So you play like this, right? But the most recent performance of this was done at the University of Louisville, and oh, not this one. Oh, sorry. There you go. And then the director sent me the rehearsal piece, and then they now play in a more faster tempo. Then I think the kick drum performer is actually like quite virtuosic at this point. Okay. All right, so. Oh, sorry. So as you can see, I mean, I think they spent more time, perhaps enjoying the piece, I hope, and then they get into it, and I think they are playing a faster tempo than I originally planned, which is also fun, but also the some performance, I can see that they are now just playing with it. They don't have to look at their fingers. They don't have to, look at the score. They are playing just like they are playing at the last boss on the game that they are really getting good at. So hopefully there is a room in my patch for the people to get better into it. As you mentioned about the Toccata patch that has been used, it is a tool, but then there is a room for the performers to get better at the patch, right? So there is some kind of depth that I hope I built into it, but I want to just make sure that that is not like required elements for you to basically start rehearsing and then testing my piece. But then after you test it, perhaps you want to go to next stages and then final boss and those kind of stuff. Okay, thank you. Yeah.
I'm Scott, and let me share my screen. Hold on. Thanks to everyone that's presented and the organizers. It's been really fantastic so far. Cool. Okay. So the talk today is Declarative SuperCollider. And I'm sort of wondering, can we tell SuperCollider, SC-Lang, what we want rather than how to get there? So just as a quick introduction, when I'm talking about declarative, what I mean is declarative programming. So this distinction, just really simply, so imperative programming, which is most programming languages that you've probably experienced, SC-Lang in a way, and many others, you describe a series of steps that produce a state. And declarative programming is where you describe the state that you want rather than the steps to get there. And I think it's probably a little bit obvious for like a kind of creative language that declarative programming has some real power. That's quite unique. So just to kind of give some context, this is a kind of ongoing research project. It was inspired a little bit by work that I did building another declarative language. Plus, I think there's a lot of interesting research going on in declarative languages and like interesting language design. So there's a lot to pull from things like Swift UI, Jetpack. It's also drawing from some really interesting work on like functional reactive animation, for example, but trying to turn this into a way to kind of describe music. I'm kind of implementing this in SCLang for now, but I'm thinking about this as something that is maybe portable to other languages or might find its home in a different language or environment eventually. But for now, SCLang is a really good place to prototype it. It's really important to me that this is incremental. I want to make a kind of like utopian version of, how we can kind of like describe cool music stuff, but I also like make music with SuperCollider and have projects and like have real things that I need to solve right now. So a lot of this is kind of balancing the incremental with the kind of bigger redesign work. So the way I want to structure this is basically this is also kind of an exposing the kind of methodology that I have, which I think might be interesting. The way I want to work through this and kind of walk through this is I want to go from a description of what is on the server, running on the server at any given point. And then I want to do a kind of series of steps to imagine how we can take that representation of like stuff that's running on the server, which we kind of know, and turn it into something that's a kind of musically expressive description. And then as we go through those steps and those transformations to kind of make the more sort of nice descriptive version, we can collect requirements for what we would have to do to kind of like transform our music language into a description of things on the server. And I think that process of collecting those requirements is really interesting. It's going to tell us like, what we need to build. And also it can reveal problems or inconsistencies and this kind of thing. So I think this is a really cool exercise. I've done this a number of times and I'm continuing to do it. So I'll kind of walk through this. So what I've got here is a basic description of what's on the server. And we can imagine that this is like the full server state. If you played this thing, this would be every single possible thing that you could set on the server in a very consistent way. And anyone that's written SuperCollider code, you probably can imagine what these things are. We've got a piano sample that's a buffer. Here's a synth def. Here's another synth def. Here's a couple synths that are playing with different parameters. And then here's an effects chain. As we're kind of looking at this like representation of what's on the server, we can already start to sort of collect some requirements that are implied here. So for example, each of these synths, it's referring to a synth def that it kind of needs to be in place, right? So the way I'm referring to stuff, I've just got a function with an environment variable, right? And that's kind of referring to this thing. Likewise, the synth needs a buffer to be defined. And for example, the input of the effects comes from another synth, right? So this is our first requirement, right? We need to reference other objects. We need some kind of like, name spacing, right? Hold on 1 second. Okay, let's maybe like take another step to make this a little clearer. So I'm just gonna like step forward here. Okay, so here's a kind of new version of the thing, right? So we only have one voice rather than 3, and we've stuck our frequencies in an array. This is, I think, probably something that everyone that's used SuperCollider has done before. And this is kind of a pretty familiar concept. So this is just multi-channel expansion, right? This is a transformation that is really, really common, but this makes this a lot more expressive. So we can kind of, not have the 3 duplicate things. Okay, so let's do a little further. Let's make this thing a piano def, right? And we're assuming that this structure def, let's sort of wave our hands and say this is some kind of encapsulated thing. So we're going to put everything for this piano in here, right? So we put the buffer in here, we put the synth def in here. Here's the voices that we had outside. And this is kind of encapsulated as a single object. And now the way we're playing it is just the same way we'd play a synth def. But instead it's actually playing this entire structure. This is a new requirement that's introduced, right? So this is like reusable structures, and maybe we can say composable structures, right? But nothing has changed about how we're defining this thing. This could be a single synth, or this could be some other set of things. All of the kind of requirements for this are kind of baked or sort of encapsulated here, right? Okay, so maybe we go one more. And we do the same thing with the effects. So we also bake this kind of effects chain that we had into a definition that has, everything that's needed. Now, something that I did here, we can kind of see is, so I'm making two synths in here instead of just one that I had before. So there's a delay and a reverb, right? So we can already start to see that this kind of encapsulation and these reusable structures means that we can kind of use this collection of synths as if it was a single synth. And we don't have to care about, instantiating these individual things. We can kind of wrap this up in a way that it's just usable in the way that we'd expect with inputs and outputs. So I think we can kind of already start to see that this might create some kind of nice composability. Okay, let's go one more. So we have a kind of thing now that we'd like to get to, right? So before this, what we were looking at was kind of an instantaneous depiction of our state of our synth, right? But we want to have a description that describes things over time and not just instantaneous moments. So let's try to think out what exactly that looks like. So here's a little example. So we had this piano, that's this structure. So what does it mean for this to kind of be a thing in time? Well, it means at time equals 5, let's say, this thing exists. And at time 10, it doesn't exist anymore. That's the kind of simplest structure that we can imagine having in time, is just something that has a well-defined time span. So how are we going to do this? I'm going to introduce this span concept, right? So this is a time span, let's say from 5 to 10. And then we're kind of wrapping our object inside of this. I just used an if thing because you can sort of imagine how this might work. If we're inside of this time span, then you get this object. If we're not inside of that time span, you just get nil. So this gives us now an object, a single description of an object that actually can sort of has an existence in time. So this is a new requirement, right? We have this kind of span. This I'm calling it kind of an existential qualifier, right? Like when something exists. And for anything outside of this time span, everything should behave as if this piano does not exist, as if it's nil. So let's see what this kind of gets for us. Okay, so one other kind of thing, I'm going to instead use a kind of operator, like I just made up this operator, rather than an if, because it's a little bit more nice looking. But one of the nice things about trying this in SELang is we can kind of play with the syntax quite a lot to come up with representations that look good. Okay. Okay, so once we have this this kind of structure in time, let's think about what it would be like to kind of perform this thing, right? So like, what does this look like if we're actually interacting with it, or we're in a sort of real-time context, because we want this to behave in a kind of real-time way as well. So I'm going to take a really simple example of keep playing a keyboard, right? So this is something that's actually like comes up all the time on forums, and people want to like trigger notes with a MIDI controller or something, and it's kind of quite hard to actually do this. There's a lot of sort of tricky programming concepts that need to be introduced to make this happen. So we're going to kind of see like what this would look like, and then see if maybe it solves some problems elegantly. So I'm going to say I have this MIDI notes object, and let's assume that this is like a dictionary with all possible MIDI notes, where the non-playing notes are nil, and playing notes are just a simple object, like velocity and a note value, right? Now, playing notes exist in time, so these things also have a span. I'm kind of noting here that like this note might start sometime, but if we're in the middle of a performance and like playing a keyboard, we don't know when the note's going to end, like while we're holding it down. So in a way, this span is actually, goes to infinity, right? This note could hold forever. And then when we release the note, this span might change to, not infinity. But these things do have an existence in time. Okay, so now we need to actually turn those MIDI notes into data that can be used by our synth. So I'm going to do this. I'm just imagining that we have this transform operator, right? Like a little arrow operator. This is going to take one structure and it's going to sort of remap it, transform it into another structure. One thing that I want to note here is because of, multi-channel expansion means that the structure of the input determines the structure of the output. So if you put in an array of a certain size, the output follows the same size. So we can kind of keep a hold of that rule and think, okay, well, the structure of MIDI notes determines the structure of piano notes. Cool. So if we have 5 notes, there's 5 piano notes. If we have no notes, if it's empty, then this is empty, right? Now, we use those notes in our piano that we defined before. So now we kind of see that this structure is also kind of transitive, right? So the structure of piano notes, if we have 5 notes, we end up with 5 piano objects, right? So this is really, really interesting, right? Because then now we've created like all of the things that are required for like playing something live and kind of lifetime, turning synths on and off. It's kind of just come out of this structure that we have. We don't have to do a lot here. If we add a note to this, it adds to that, it creates another piano in this structure. So I think this is already, we're starting to see some really interesting things that come a little bit elegantly here. Okay, let's go a little further. Okay, so when we have these note events, this can also be like a not live, but it could be like a score, for example. So we imagine, let's say, 3 notes with different time spans, and let's say we have this note event transform that's kind of going to do that thing where we turn it into a frequency. Well, this thing here all of a sudden starts to look like a p-bind, right? This is a bunch of events happening in time that get kind of transformed into a different object that we can kind of consume and connect to a synth or something like that. So all of a sudden now we're seeing these ways that we can connect existing SuperCollider objects into this structure. Okay, so let's go a little further with this. So what if we want to create a monosynth, right? So rather than having 3 separate nodes or different nodes that are overlapping, we want to make something where we have a single synth and we're kind of changing the frequency parameter rather than on that single synth, rather than having this kind of polyphony, right? So let's imagine what that looks like. Well, what we've kind of done here is add this flatten operation, right? So we can imagine what this might do. This might take a bunch of notes, like a list, and flatten them into a single object, right? And then this gives us basically then note events is one item. So we can see what this looks like. We have something like this, right? That means that we have one piano, right? So now we're monophonic. Now we can imagine how this flatten happens, right? So for example, this is 3 different degrees at different times. So maybe, we say, okay, this gets turned into, let's say, an envelope, right? Some time varying thing where it's like, first we're 0, then we're 3, then we're 5. Now we can imagine different ways of doing that flattening, but like this is what a kind of like, this is the equivalent to P mono. So again, now that we can imagine something like this flatten operation, then we kind of get, poly or monophonic note playing sort of for free coming out of this system, right? And if anyone's looked at the internals of P mono, it's really, really sophisticated and there's a lot of complexity. It sort of doesn't always work, right? So we're getting something quite elegant here. Okay, so we'll do one more kind of operation. Oh, okay. So yeah, this adds a requirement too, which is flattening. So we have to think about what this kind of flattening operation means. We probably need some rules as far as like what, how this happens. Okay. Okay, so what if we want to take this single event and turn it into an array, a collection, right? Because it seems like there's a concept there where we want to be able to produce collections of things. So let's call this remap. So remap is going to produce a collection where the keys in that, like it produce a dictionary basically, where the keys come from the properties of this object. So let's say remap key, when we specify degree, it's going to give us what we want is a dictionary where each of the keys of that dictionary is the degree of the objects that are coming in, right? So it's going to give us something like this. So our degrees are 0, 3, and 4. So this will give us a dictionary with keys that are 0, 3, and 4, with an object for each of those. And since this is this is something that changes over time, then each of these has a span, a time span. And now we're kind of back where we were before. We've gone from this mono representation back to a kind of polyphonic representation. So this starts to feel like actually this remap operation and flatten are kind of the same thing, maybe done in reverse. So we can start to already see connections between these things, right? Where maybe actually, if we think carefully, this kind of operation actually encodes a lot of really interesting things that we can do to musical structures. Cool. I'm going to give one more example really quick because I'm running out of time. Let's imagine what a more sophisticated version of this is. So I have now this clang def. We can kind of ignore what's in here, but let's say this is a structure that's not only just something that's fixed in time. This actually has spans in it. So you give it a time span and it might generate events in time, right? So this might be a musical phrase or something. So then we can use this structure the same way we're using other structures. And then we can transform it with this list of different time spans and parameters. And so then, again, structure follows, using our kind of rule from multi-channel expansion. So this now becomes 3. This goes into our piano. And so now actually what we have is 3 kind of musical phrases with different timing and different parameters that we've kind of defined all the complexity of that structure elsewhere. And we can kind of like score these in a really, really simple way. And we haven't even attached these to a synth yet, right? These are just kind of events, just kind of properties. So I think that we could easily plug this into a different synth or a different structure. So you can kind of imagine how you start to build complexity here in really interesting ways. And the kind of endpoint of this is something like this. This is, you might have your entire performance, which is defined by some structure. And then maybe you pass in objects from the outside, like you might pass in your MIDI controller or some real-time control object, or maybe you pass in recorded automation. And those things would kind of work interchangeably. So you can maybe see that there's this kind of like really nice structure of kind of composition of objects here. So I'll just kind of finish this. So the status of this right now, this kind of first slide that I showed, this kind of server state, object is kind of working. I have a working version of this. I think a lot of work is needed, but handling this kind of like describe the server and then put all the objects there with node ordering and stuff. This is sort of working. I have some of this transformation stuff prototyped out. I'm kind of exploring the reusable structure part. But overall, I think this exercise that I just showed of kind of moving from a sort of representation of what you want and then sort of doing transformations back to something that is kind of musically expressive, or going in the reverse direction, going from a kind of imagined musically expressive description of this is what I want my, musical phrase to be, and then doing a series of transformations until you get to the kind of server representation of it. It's a really interesting exercise because you can collect these requirements of like, what do we need? You can find holes and problems with it. And as I've done this many times, and as I go, I'm kind of refining what those concepts are. So even in showing what I just showed, there's already some sort of things I would change about this as far as how these things are represented. And I think it's a really nice way to kind of incrementally work on different topics and kind of push this forward. So that's all I have. I'm happy to talk offline. I don't know if we have time for questions, but please hit me up if you have questions about this more. And I'll try to release some code. I'm hoping by this summer I can have a very early kind of alpha version of this.
Okay, cool. Thanks so much. My name is Joel Ong. I'm an associate professor in the School of Arts, Media, Performance, and Design at York University in Toronto. And I'm a visual artist, and I think my works are mostly characterized by fluidities between digital and analog domains. And really my brush with SuperCollider came from working on a PhD at DxArts in Washington, Seattle, and inevitably in close proximity to people like Josh Parmenter and Mark Chin who's sitting in front there, you get very influenced and inspired to do things with that. So by no means am I an expert. I wouldn't consider myself a developer. I would be very, very excited to see where this goes and how this can feed into more multimodal structures of art making and maybe explorations of creativity. So I really hope today's presentation is like an entertaining one and hopefully something inspiring as well for you to ask more questions about. I have 3 projects that I'll focus on and maybe a bunch of images that I'll throw past you. But if you're interested in talking about anything, I'm happy to go into the weeds of it. I hope there will be some roots there as well as we pry the weeds. But let's see how this goes. Okay, so the first project I'll talk about is a project called the Birdsong Diamond, which I worked on with people at UCLA. From 2015 to 18. It's a collaborative project that started from evolutionary biologist Charles Taylor's desire to understand more about bird communication. And at the time, he was looking at coded languages, possibly for military use, but it's more about trying to understand, I guess, nature around us. So there were a couple of different aspects of the piece. But one of the main ones that I worked on was this part called the birdsong mimic, where we were trying to utilize the call and response characters of birdsongs to inspire kind of gamification of birdsong emulating. So in this, you'll see there were 2 domes actually positioned. This was in Governor's Island. This was one of the first places that we did this up in New York City. And you can see also HarvestWorks directors, people over there. And what they were doing was responding to a prompt to sing like a bird song. And you would then whisper, and then you would kind of sing your bird song into a parabolic microphone, and it would rank you or rate your similarity to a bird. We also started doing this in bigger places, I guess. We did this in Times Square. It was very well received, and people really got very, very much engaged with it. And some people even brought musical instruments too, like a flute, which actually turned out to be really fantastic. And of course, kids loved it as well. We got some of the Spider-Man people in costume as well working on this stuff. And part of it also is, I think I'll show you a little bit more about how it goes later. Great. But a sense of how it was installed in space. This was in Mexico. And a lot of the visuals were generated by different members of the team as well, using a combination of JS and touch designer. But some of the audio files that we were generating, people recordings, as well as the final rankings of the data on their frequency analysis was also being fed into the program over OSC. This, I think, was our biggest show.
Now mimic the bird song after the beat.
2017 now. Yeah, we were utilizing their 8K stage, and so it was almost framed as a performance or like a dialogue where we were trying to transfer files across one station to the next, so it almost felt like we were communicating true bird songs, or someone would try to emulate a bird song, and then their recordings would be transferred to the other person. So you get this infinite regress and maybe a degradation, essentially, of humans' attempt to communicate like a bird, which maybe was part of the point, to show that there isn't a way that we can enter that envelope of a bird, essentially. And this was the SuperCollider patch that I wrote at some point, and I can even show probably a live demo later if the speakers work. But very, very simple backend. It does a frequency spectrum of the sound coming in, or actually the sound sample first, so you can choose what bird. I mean, it's actually on a random loop at this point, but you can choose which database you would like to sample a bird from. It takes the bird song, maybe about 4 to 5 seconds of it, gets an array of pitches, and then it records your input, gets an array of pitches as well, does a little baseline matching, and then just with simple math just calculates how well the overlaps are happening. So something interesting also everywhere that we have presented this piece, we have also gotten in touch with avian enthusiasts in that area and found out more about the kinds of birds in that region. So for instance, when we did it in New York, we were looking at birds that were typically getting hit by high-rise buildings or crashing into high-rise buildings, and that became an issue as well. And also bird songs, I guess, that were on the verge of extinction in places where they would move away from due to climate disruption. Okay, so the next piece that I'll talk about was something that came out of my time at DxArts, and you were talking a bit about the ATK, and it's working a bit with Wang Tenpin and Joe Anderson as well. And as we were working on this piece, I had this idea of developing a multi-channel sound installation that would sync wind with sound. So this was the first prototype where I was building a kind of 6-channel soundscape where you would feel a gust of wind at the same time as you would experience sound. And a lot of it was about whispers and how whispers would kind of feel like breaths on your skin. And the intimacy of a particular performance like that. And I was also looking at some data visualization techniques, I guess at that point in processing. This was some time ago, and on UN migration data. And if you remember in 2015, there was a huge migration crisis, not unlike the current one also. But there were many refugees that were coming in from the Middle East and Syria in particular. And we were looking at things like visa restriction indexes, where they could go. And so this data visualization project just mapped countries of origin to duration of them, like these particles floating in the air, to kind of feel like they were kind of suspended in limbo and not being able to go anywhere. So at some point, we connected fans to them because it also felt like wind was a great metaphor for passage of motion. If you have the wind in your sails, you typically can get faster to the location you're thinking of, or something to that extent. So I made this little interface that would change as it went through the data set. So depending on the countries that it was sampling for at that time, it would change the intensity of the fans in a bit of a circle. And the visualization also in the orange parts were the countries of origin that had very low visa or very high visa restriction indexes, which meant they had the least mobility around the world, and so they would be suspended the most. So it's kind of simple mapping. It's very inspired by Scott Hassel's celestial mechanics at that time, so the color scheme is somewhat similar. So this was the installation at the Currency and Media Festival in New Mexico some time ago. And you can see this a 16-channel ambisonic sphere and something like 24 channels of fans to provide the ventilation and the visualization projected downwards onto a circle that was somewhere else. Incidentally, the mapping of the locations, they were geolocated around a sphere, and that kind of matched the ambisonic polar coordinates of where things were going. So there would be a Bezier that was moving in the visualization, a dot from one country to its location or destination. For instance, if somebody was moving from the Middle East to, say, Canada, there would be a line that was crossing over, and as well as that, there would also be a corresponding sound that would move from in the ambisonic sphere as well. There were some scaled down versions of this. This was a 4-channel, still somewhat connected, the sound and the wind. At Nuit Blanche was a night festival in Toronto. We also showed this with a Twitter interface as well, which allowed you to Twitter interface. That dates it, which allowed you to upload stories as well, and that would appear on a virtual or a kind of 3D constructed a city. And the last piece that I would talk about, the third piece I would talk about is something that I've been preoccupied with in the last couple of years now, and that's bio-inspired design, I guess, and not really just thinking about simulations or biomedia kind of interventions, but actually getting down and dirty and trying to understand interspecies relationships a little bit more. So this is a project called Untitled Interspecies Umwelten, where I attempt to understand what it is like to be a Euglena gracilis, which is a single-celled algae that forms pond scum, the green layer on a pond. And there's a mixture of text generation and sonification of real-time data. So it's a simple OpenCV type implementation through Python, which sends OSC data over to SuperCollider to generate a soundscape. But also there's an API that connects it with OpenAI and some LLMs that have a creatively organized prompt generation system that allows it to tell a story about its own life. And the general idea for this particular piece was to think about sentiment analysis and how can you kind of reach deep into another organism's psyche, if we could say that, if that's not anthropomorphizing it too much, and find out what are different states or valences of emotions they may potentially have. And there's something in there about disrupting some of the biocapitalism that's going on, the co-opting of organisms into these large industrial complexes that perhaps we need to care a little bit more about, not so much how they feel, but in general what their effect is on ecosystems and ecosystem damage. So in order to do that, Euglena are really tiny, so that was a 400 times magnification. So essentially it's a microscopic endeavor. And so we created a microfluidics chamber with some collaborators at York. And essentially it was a stage. You can see there are two circles, two tiny circles in the 3D model, the CAD file that were stages for them to go in. But there was also like a couple of loops that we call like the playground side, where they could actually swim around and be happy. And they were also, they're also photosynthetic. So having it backlit was a very happy medium for them. And so they enjoyed it for the 12 hours that the light was on a daily basis in the gallery. And they grew, actually. to a point where at some in certain images of it, they actually became too congested, and we had to flush them out, unfortunately. Yeah. Yeah. Talk about care. I don't know. That was. We immediately had to think about, like, okay, a death cycle now. We're talking about a life cycle. What's the afterlife of you know? Anyway, these were, of course, these are questions you contend with when you deal with life in such a context. Okay, so this was one of the screen captures. I guess there were a couple of different iterations as well, but it's not Zoom. Yeah, so there is a sentiment analysis that's going on that takes the overall sentiment of the plate, and then it creates maybe tension or harmony in the frequencies that are coming out, but also a kind of cycling beat that shows some notion of liveliness in the dish. And of course, the text that's being generated on the left side it comes from an LLM, and we're looking at certain parameters of constraint and illumination, and that's actually converted into the way that the text is being fed back to the program, So if the dish felt more constrained, then the text that was coming in would have less space between them. But if they were, a lot of them were moving and they were happy, then the text that came back was kind of spread out. There were a lot of spaces. And it's not meant to be legible. There is a machine speak which is legible, but the Euclidean speak, is not. And again, maybe that's the thematic that's running through these projects, where the bird songs are not meant to be legible. They're meant to be almost a humorous, self-reflexive, Sisyphean endeavor of trying to speak like some other species. Okay. There are some other works which I was considering talking more about as well, but they utilize SuperCollider as a central control panel for conducting controlling movement of servo motors or stepper motors through Arduino, which you probably know quite a lot about it already. So I wouldn't consider that like a step forward. This was another couple of pieces that use some of that. This delayed polynomial errors as well, and we're showing some of this too back when. And also how it could be naturally a nice visual interface as well. I don't think that gets talked about too much, but the GUI function is also quite useful. And you've seen in the previous presentations also how you could use it as a democratizing tool. Like, you don't need to know what's behind the GUI. If you want people to get up and running with it, you can immediately send that to them and have them run it. This also was a piece that was done. I can't remember when now, but it was called Spatial Measure, where I used CMU Sphinx to do a very rudimentary voice recognition analysis. This was back when, before all the AI stuff started coming out. And it also used Marchin's WS GUI here, where people in the gallery space could actually type in words as well. If the radio wasn't playing anything that was legible in the system, they could also type in words. But generally, the system would listen to the radio. It was a BBC broadcast, and it will pick out important words, and then it will run like a YouTube. It would amass YouTube videos, and so in the 8 channels around, you would hear a whole bunch of stuff going on. And it was interesting because, I mean, one of the things that came out was somebody was talking about a cure for HIV, and then they started playing The Cure in 8 channels, which is like, oh yeah, nice. While they're talking about HIV, okay, fine. Yeah, and so also a couple more, moving pan tilt motion sensors around, and this also is a kind of tribute to my supervisor, Juan Pepin, who was also working a lot at that time with parametric speakers. So, you know, he really was the guy who was helping me out, getting me started, I guess, on SuperCollider back when. But yeah, that is my quick presentation.